Hello everyone, my name is Ghorbani. I'm Associate Professor of People's Fellowship University of Russia. Today I'm presenting the paper entitled Analyzing the beer bearing using direct spectrum method when transferring the torque motion from the machine. Objective of bearing is to provide relative positioning and rotational freedom while transmitting a load between two parts. And the most common type of bearing supports a rotating shaft resisting purely radial loads or a combination of radial and axial loads. The components of a typical rolling contact bearing are the inner race, the outer race, and the rolling elements. The load, speed, and operating viscosity of the lubricant affect the friction characteristics of the rolling bearing. The designer must deal with such matters as fatigue, friction, heat, lubricant, kinematics problems, material properties, machine tolerance, and so on. The main problem is that rolling bearing is subject to various types of loads, and the failure occurs because of wear, dirt, hard particles, and electric pitting, rotational creep, and by damage also. The early bearing failure occurs at very high speed, very high, low and high temperature, and very heavy loading conditions. It will lead to high temperature, high frictional torque, excessive deflection, and consequently unwanted vibration. So that's why the detection of the running state of the bearing and roll diagnosis are essential. One of the requirements for the diagnostic parameter is the ability to determine the type of wear. Detection of dominant type of wear makes it easier to measure and provide solutions to reduce or eliminate the error, which can extend the service lifetime and the rolling wear. And vibration is also an important issue to detect the fault in rotating machine. The main problem statement of this study is related to the diagnosing in the bearing wear using the direct spectrum method and prove that advisability of its use during the transmission of the torque motion from the machine tool. For this purpose, we determine the diagnostic parameter to determine the moment of the failure, and investigate the sensitivity of diagnostic parameters to various types of wear that reveal the influence of vibration and noise from the main drive of the lace on the diagnostic parameter, and we make a conclusion about the advisability of the applied method. We use 6 types of rolling bearing with different types of wear. We carried out all the experiment on the lace machine. As you can see, we put a sensor on the rolling bear to detect the vibration, and in this slide you can see the steps of the test. So we use spectrum analyzer A17U8 the company Zadeh to record the vibroacoustic signals during experiment, and after that we got the result, vibroacoustic signals and so which indicate that the bear wear in the form of the mechanical wear leads to an increase in the noise level in low frequency range. The noise amplitude of a worn bearing 59 is 2% higher than that of a worn 58%, and the lack of lubrication in the bearing and the presence of corrosion leads to an increase in amplitude frequency in the high frequency range of 4,000 10,000 Hz. The amplitude of the bearing without lubricant is 104, and the bearing with corrosion is 106, which is 30% and 60% higher than the amplitude of the worn bearing 68 respectively. And the presence of abrasive chips in the bearing lubricant at an early stage of clogging increase the amplitude in low frequency, while the presence of significant amount of chips in the lubricant increases the amplitude at all frequencies. But this is especially noticeable in range of medium frequencies. So as a conclusion, we can say that the obtained data showed that the criteria for comparing the spectra make it possible to detect defects at a significantly lower amplitude of the bearing signal or at a stage of the development of defects. And the main advantage of the proposed method is the ability to diagnose bearing and working requirements, and without disassembling its units, it reduces the cost and of repair work and prevent emergency failures. Thank you for listening.